This is Mrs. Show. Today our objective is to be able to add and subtract radical expressions. Remember, when we add and subtract fractions, what do we have to have? In order to add fractions, you must have like denominators, right? Common denominators. In order to add radicals, you must have like radicands. So radicands are what's underneath the radical sign. So looking at these two examples, do these radicals have like radicands? On the first one, I see a 3 under the radical sign and a 2 under the radical sign on the second term. These are not like radicands. If you look at 4 radical 7 plus 3 radical 7, those do have like radicands. So you can add these together. You would add 4 and 3 to get 7, and you would have 7 radical 7. On the first one, that is simplified. You cannot add because the radicands are not the same. Looking at number 1, in order to add or subtract, we need like radicands. Well, they both have a square root of 11, so you can add them together. 6 radical 11 plus 9 radical 11, I would add 6 plus 9 to get 15, and then I would have radical 11. On number 2, I have radical 3 minus 5 radical 3. The radicands are the same, they're both 3's. Remember, this is like a 1 radical 3. So I'm taking 1 radical 3 minus 5 radical 3. I'm taking a 1 minus 5. A 1 and a negative 5 make negative 4, and then I would have radical 3. On number 3, I do have like radicands. I have radical 2 and radical 2. So I can subtract 7 radical 2 minus 8 radical 2. 7 take away 8 is a negative 1 radical 2. If our coefficient is a 1, we really don't have to write it. You could just say that's negative radical 2. On number 4, I'm looking at radical 3 for the first term and radical 12 for the second term. They are not like radicands. This one is a 12, this one's a 3. But I am noticing there is a perfect square number that goes into 12. I could simplify this. So I have a 5 radical 3 minus 7. This 12 is the same as radical 4 times radical 3. Well, radical 4 is the same as a 2. So this is a 2. I have a 7 out in front. 7 times 2 will give me 14 radical 3. So what I have is 5 radical 3 minus 14 radical 3. Now my radicands are the same. I could combine those. I could do 5 minus 14. That's a negative 9 radical 3. Looking at number 5, I have a radical 7 and a radical 28. These are not like radicands. So I'm noticing there is a perfect square number that goes into 28 though. That is 4. 28 is the same as radical 4 times radical 7. Radical 4 is the same as 2. So what I have here is a 2 times 2 radical 7. So 2 times 2 is 4. This simplifies to 4 radical 7. And the first term was a 4 radical 7. So I can add 4 radical 7 plus 4 radical 7 to get 8 radical 7. So remember, in order to add or subtract, you have to have like radicands. So looking at number 6, I have a radical 32 and a radical 18. My radicands are different. But I could simplify. I'm thinking of a perfect square number that goes into 32. Let's see, what perfect square numbers? If we think 1, 4, 9, 16, 25. 4 will go into 32. So will 16. I'm going to use 16 because 16 is larger. So I'm going to think of this as 5 radical 16 times radical 2. What is a perfect square number that goes into 18? Could I simplify radical 18? Yes, I could. 9 does. So I could think of this as radical 9 times radical 2. Well, square root of 16 is 4. So this is 5 times 4 radical 2. Square root of 9 is 3, so this is 4 times 3, radical 2. 5 times 4 is 20, so I got 20 radical 2 for my first term. 4 times 3 is 12, so this would be minus 12 radical 2. Now I can subtract these because the radicands are both 2's, so if I take 20 minus 12, I get a radical 2. Our objective today was to be able to add and subtract radical expressions. Your assignment today is not out of the Big Ideas textbook or website. It is on IXL. What I need you to do is go through the Perry Township website. So go to the Perry Township website, click on IXL to log in, and you're going to do skill EE5 under algebra. So you're going to skill EE5 in algebra. I want you to continue working in this skill until you have it mastered.